Namaste, this is BSc B.Ed second semester class of State of Matter and Nuclear Chemistry, and topic is HSAB. HSAB means hard and soft acids and bases. The Lewis concept failed to provide definite and uniform scales to measure the relative strength of acids and bases. You can see here this reaction that A plus A dash B forms AB and A dash, means A dash B is converted to AB. A is stronger than capital A. It may be said that the relative stability of acids base complexes are used to express the relative strength. So one of these difficulties with different references acids different trends were observed in Kf delta G0 and delta H0. For example, the complexing ability of the halide ions like towards Al plus 3 increases in order of I minus is lesser than Br minus is lesser than Cl minus and F minus. So finally we get that the acid and bases, classification of acid and bases. From the above displacement reaction, it may be stated that B1 is softer than B2 when K1 is greater than 1 on the basis of the list of hard and soft acids and bases may be obtained. The classification is not rigid and there occur a gradation from hard acids to soft acids and hard bases to soft bases, including the borderline species. So the criteria of hardness is ascribed to the hardness of the electron cloud associated with a particular species. A firmly held electron cloud having low polarizability makes the species hard, while an easily polarizable electron cloud characteristic species is soft, and the third category with intermediate characteristic will be a borderline. The detail of distinguished feature of hard and soft acids and bases are summarized in this table. So this is a table for acid where first column shows the hard acids and the very much right corner shows the soft acids, and in between borderline acids are shown. So we can characterize the acids hard and soft acids. Hard acids are small size and soft acids in large size. Hard acids high positive oxidation state and zero and low positive oxidation state in soft acids. Absence of any outer electron which are easily excited to higher state. And in soft acids, presence of several excitable valence shell electrons. Hard acids, absence of d electron shows, and in soft acids with nearly full d electrons are shown. In hard acids, usually light metal ions, and in soft acids, mostly heavy metals ions are soft acids. So low as Lewis acids, which are not easily polarizable, prefer to coordinate with hard, and in soft acids known as Lewis acids and are easily polarizable, prefer to coordinate with soft bases. And this is a table for bases where hard, soft and borderline bases are shown, and features of hard and soft bases are shown in this table. So you can see here that the hard bases are highly electronegative and soft bases are low electronegative. Hard bases are low polarizability and soft bases high polarizability. Presence of filled orbital empty orbitals may exist at high energy levels in hard bases, and partial filled orbitals empty orbitals are low lying in soft bases. These are anions and neutral molecules known as Lewis bases and ligands prefer to coordinate with hard acids, and these are anions and neutral molecules called similarly Lewis bases all ligands prefer to bind with soft acid. So this is about hard and soft acids and bases. Finally, now the limitations of hard and soft acids. Hard and soft acids classification is useful concept, no doubt, but it has some tricky limitations as pointed out below. The prime limitations of HSAP concept is that it is widely general and has no any direct quantitative scale of acid-base strength, and the inherent acid-base strength are not accounted for. Example, OH minus ion and F minus ion are both hard bases, where OH minus is nearly 10 to the power minus 10 to the power 13 times stronger than F minus ions. Correlation between hardness and inherent acid-base strength is yet to be developed, and interpretation of different reactions by splitting the participants into acid-base fragments is quite arbitrary and some of extent, and reactions between ethanol and acetic acid may be interpreted for esterification in two ways. So the hard combination of H plus, the hard combination of H plus with OH minus and both justifiable, but there is nothing to exclude the on the basis of hard and soft interactions between CS3COO minus and C2H5 plus. Sometimes hard soft principle fails to keep partially with inherent acid base strength. So these are the limitations of hard and soft acids. So this is about hard HSAP principle. Thank you so much.